On July 30, 2020, NASA successfully launched the Mars Perseverance rover into space. After traveling for 300 million miles at the speed of about 24,600 miles per hour, the Perseverance rover landed on Mars on February 18, 2021. But what if NASA wants to explore other planets like Proxima b, which is 4.24 light years away? Unfortunately, we can't. The current rocket propulsion technology, using either chemical-based solid or liquid fuel, hasn't changed significantly since it was originally developed in the 1920s. This type of rocket fuel is very limiting and not suitable for manned interstellar travel. But the good news is that scientists and rocket engineers are currently working on a new type of rocket called an antimatter rocket that could hit speeds of 72 million miles per hour and potentially become the spacecraft for future interstellar travel. My name's Aung Zaw, and this is antimatter physics. Antimatter are molecules formed by atoms consisting of antiprotons, antineutrons, and positrons. Antimatter particles are identical to matter particles, but the subatomic particles of antimatter have properties opposite to those of normal matter. The modern theory of antimatter began in 1928 when an English theoretical physicist, Paul Dirac, set out to reconcile the laws of quantum theory using Einstein's special theory of relativity. This was a remarkable achievement in its own right, but Dirac realized that his calculations would also work for an electron with a positive charge, an unanticipated result. When particles of matter and antimatter attract each other and collide, they don't just smooch around like they found their lifelong partners. In fact, they have much better chemistry between them, producing 2 X-ray energy photons and total annihilation in a flash of energy. While tons of chemical fuel are necessary to propel a human mission to Mars, just tens of milligrams of antimatter will do. Isn't it simple to produce 10 milligrams of antimatter? Not exactly. All the antimatter particles created at the Fermi Lab's Tabitron Particle Accelerator only account up to 15 nanograms, and 1 nanogram at CERN and 2 nanograms at DESY in Germany. If all the antimatter that we've ever produced were to be annihilated at once, the energy produced wouldn't even be enough to boil a cup of tea. Another problem also lies in the cost and efficiency of antimatter production and storage. Making just 1 gram of antimatter particle would cost 25 million billion kilowatt hours of energy, as well as $1 million billion. Star Trek Starship Enterprise uses matter-antimatter annihilation propulsion for faster-than-light travel. While antimatter vehicles are still the stuff of science fiction, if one day we can create or collect large amounts of antimatter, their studies might help antimatter-propelled interstellar travel become a reality.